KYEL TV presents its public affairs program, Dimension 13, with your host, Dave Marquis.
Good day, and welcome to this week's edition of Dimension 13. I'm Dave Marquis, the news director here at KYEL, and this week we have an especially interesting program. We're going to be taking a look at the Central Arizona Project, or parts of that project, and we're going to talk about a little bit about its past, its present, and its future. And with me today is Ed Hallenbeck, who is the project manager for the Central Arizona Project, and formerly the project manager here at the Yuma office of Water and Power Resources. Welcome to Yuma again, Ed.
Thank you, Dave. Nice to be back.
Yes, I imagine that the only thing that's changed is you have your hands even more full than you did when you were down here. And
well, I sort of miss this town. When I do come back here, you sort of wonder why you left this community and went to a town the size of Phoenix, particularly driving to work in the morning through the traffic, but the job has been very interesting.
Okay. Well, as many people know, the Central Arizona Project is the largest congressionally funded water project in this nation's history. And as such, it represents a terrific opportunity for many people in Arizona, many diverse interests. What's it been like to suddenly jump in and be in charge of such a massive project?
Sort of overwhelming. I think I'm still in the learning stage, and I probably will remain in that learning stage for some time. The project itself is, although it's physically one of the largest, it may not be physically the largest, but due to inflation and that it has become financially the largest single project ever funded. Not too sure we want to brag about that.
Well, now, in terms of water eventually to be moved, how will it compare to other similar projects in this country?
It's sort of middle-sized in terms of water because the Colorado River is a little bit on the lean side itself. It has the capability of moving about 2.2 million acre-feet of water into the central Arizona area, but we calculate that over its 50-year life, it will probably average about 1.2 million acre-feet over the 50 years. The Colorado River, is a little bit oversold, and this is Arizona's last chance to dip into the Colorado and bring it into the central part of the state.
Well, now, one question that comes to mind, I've often thought about this, but haven't had anybody to ask before. When the project is completed and the water is being drawn from the Colorado River, won't we still see the same flow throughout the rest of the river because of the fact that all the dams have pretty well filled up along the Colorado River watershed?
Yuma would notice the reduction only in terms of excess water years, such as you have had this year. If the Central Arizona Project had been on the line, the water that was flowing past Morales Dam here and going into Mexico, not even to be able to be utilized by Mexico, but flowing to the Gulf ultimately, that would no longer happen. All of the Colorado would be utilized in the United States or Mexico.
So what we're going to see then is another means really of controlling excess flow in the river while using the water more effectively in the state.
Right. There has been some concern about the people in the Yuma area and along the river that the CAP is going to be pulling water out to such an extent that since they're upstream, Yuma will go dry. That is not a real concern at all. Provisions have been made in the legislation that Yuma and downstream users will be guaranteed as much water as their water rights give them.
And that's legislative built right into
That's built right in, and it's a matter of law, so Yuma shouldn't have to worry about CAP taking the water away.
Okay. Now, most people, I'm sure, that have been reading the paper or watching the news in the last 6 months are aware that there are three major user groups: agriculture, urban areas, and then Indian tribes that will be served by the CAP. And of course, there's been a measure of controversy, as would naturally happen. They're competing for that water.
Right. That controversy is probably the understatement of the year right now. We're all a little bit disturbed over the fact that this controversy ever did arise, because water has been a subject of enough controversy in the West where it's short to have to be wasting our energies and efforts in this area. But we do have quite a controversy brewing right now, particularly over the Secretary of Interior's most recent allocation to the Indians.
Well, now, in the way that this affects you, as really basically, well, an administrator, but an engineer also, this makes your job tougher, doesn't it?
Well, it makes some of the decisions that we have to make a little bit more difficult to nail down. We have some sizing of facilities to perform before we can get them engineered and get into the construction stage. The lack of finality of these allocations makes that particular job more difficult. It doesn't make it impossible because we feel that the allocations as the Secretary promulgated them for the Indians in terms of quantity will probably remain about where they are. May vary slightly, but they won't vary to any great magnitude. The controversy has been principally around priorities, and the way the Secretary has set these allocations up, that the Indians have approximately an equal priority during periods of shortage with municipal and industrial, where the non-Indian agriculture is more or less the first one to go. You could conceive then that the city of Phoenix would be having a water shortage while Indian agriculture would flourish. I don't think anybody wants Indian agriculture not to flourish, but the equity of that is being questioned.
Okay. Well, now let's go ahead and take a look at we have a special map here that we can follow the progress and look at the route that the CAP will take.
One of the fascinating things about the CAP is that it physically is so large. And if you fly over Arizona, this area of the map here depicts the Colorado River. Parker Dam is approximately in there. And over here is Phoenix. And then here's the good old Salt River that ends on up going in with the Gila and down to Painted Rock and ultimately flowing through Welton and into Yuma.
Okay, now we were a little bit late getting onto that. Can we just look up here on the left? Now we're talking the Colorado River runs along
right
there.
along this border of the diagram here.
Okay.
Now those, are you familiar with the Bouse area? This is Bouse Hills. We have a pumping plant there called Bouse Hills Pumping Plant. We're going to be looking at some slides and videotape down the road here in a few minutes. And what we'll be starting out is up here at the Havasu pumping plant. This is the largest pumping plant on the stream. This lifts water 800 feet from the Colorado up into this tunnel, which many of you have heard about. It's 7 miles long. It was bored with a mole, a great big drill.
And we'll see that later,
You'll be able to see that. This reach right here that's in green is not under construction yet, but it is a widened reach used for storage. And all of this in red is presently under construction. The system, or completed, the system is about 30% finished. So it's very visible, and it's hard to miss when flying over the state.
What does it look like from up there from a plane?
Today it looks like a big white ribbon of concrete. There's no water in it except this little reach of 5A right here has some water in it. But
okay. Well,
very plain to the eye.
Okay, well our film is ready. Why don't we actually take a bird's eye view of how some of this has come about and come along.
We'll be starting out at Havasu. This scene you have before you right now is about 2 years old, and this is the site of the Havasu pumping plant. And a picture taken several weeks ago from the same site. This is the construction of the plant in progress. The plant there is approximately 10 stories tall and sitting in a 10-story deep hole in the ground. This is another view from the same area, looking from the land back out into the lake. You can see above in the water up there, there's a dike. This prevents the muddy waters from the Bill Williams, when it does flow, from mixing with the water that will be coming into the pumping plant. And there again is the pumping plant as we see it very recently.
How near completed is that then?
The structure itself is probably 80% complete, but inside that structure then is very a large amount of work in terms of installing the pumps, motors, electronic control systems, and what have you. The pipes come out the back of the plant here. You can see down towards the bottom of the picture, it's sort of rusty colored. Those pipes are 12 foot in diameter. They're sort of hard to picture the size. And they go 800 feet up at about 45 degrees up the face of Buckskin Mountain.
Okay. What kind of flow through there are you going to have?
There will be a combined capacity out of the two pipes of 3,000 cubic feet per second.
Okay.
Now here's a view from the mouth of Buckskin Mountain Tunnel, where the water ultimately enters the tunnel. This is looking back down at the pumping plant site and that dike again.
800 feet below.
800 feet below.
And this is the Colorado River looking back over it there.
Right, looking up towards Havasu City. Now here's the Buckskin Mountain Tunnel, the orifice as it the mole came through, and this is as it looks today.
4 separate passageways for water.
Right. The 2 bottom ones are actually where the pipes connect. The 2 top ones are gate galleries, where the gates that you can shut the flow of the water off. This now is the mole as it holed through about 2 years ago.
It just chewed through that rock.
It just, you know, just literally pushed its way through with those cutters gnawing the rock away. They've now taken the head off the machine, and this is part of the conveyance system that brings air and conveys out the material that it cuts. Now this is the tunnel as it looks today, from the bifurcation where the 2 pipes connect, looking back up the tunnel. It's 22 foot in diameter. It was made with precast liners. They're 4 foot wide about and approximately a foot thick, and there's 4 sections. You can sort of see those sections around in the wall here. This picture was taken approximately the middle of the tunnel.
And how long again is that tunnel?
About 7 miles.
7 miles through solid rock.
And here it comes, right, here it comes out the other end.
And then there you begin an actual
Reach
section of...
1, yes, Reach 1, the one here that wasn't finished yet. We're starting. Right downstream from Reach 1, which is about 12 miles long, is the Bouse Hills pumping plant, and this was built largely in very good rock. And as you can see, quite a bit of colorful blasting went on in order to make that hole that you see before you right there. These pumping plants look pretty much alike. They're all, the canal flows down into the plant, and the plant is pretty much underground. This is the little Harquahela pumping plant, which is downstream a little further from the Bouse Hills plant.
That's the one of the proposed sites for the hazardous waste dump, we might mention.
In that general area, yes. A little controversy came up
over that.
about that earlier.
Yes.
This is a section of canal under construction just down from the Bouse Hills plant. Now this is Reach 5A. This is an area that we lined and plugged both ends, put water in it for test purposes. In addition to the Buckskin Mountain Tunnel, there were several others. This is the Burnt Mountain Tunnel. It's about 3/4 of a mile long. It was not drilled with a mole as the Buckskin Tunnel was. It was conventionally drilled and blasted, and it has a slip form lining, aluminum lining form that they slide down the tunnel, pump concrete behind it, and it makes a very smooth inner lining as you see there. And this is coming out of Burnt Mountain Tunnel looking towards the Hassayampa River, and there's a short section there, and it drops under the Hassayampa River for about 3/4 of a mile, and it does this in a large pipe. Those pipes are again 22 foot in diameter, but each section weighs 225 tons. And they were so difficult to move that pipe mobile there had to be constructed specifically to move them.
Especially for the job.
Just for that job. Now here is the Hassayampa pumping plant site about 1.5 years ago, and here's the Hassayampa site today.
Now the pumping plant, what is it actually doing?
It merely lifts the water, like this one lifts it 200 feet from that canal into a canal that's above it, 200 feet higher.
Okay.
The concrete, when you pour concrete in the place concrete, I'm an electrical engineer, I never can place, I always pour it. But in the summertime, the temperature of that concrete has to be kept down at a prescribed level, otherwise the strength is gone. And that plant right there has an enormous ice machine associated with it. And in the heat of the summer, in August, they are using almost entirely ice rather than water in the mixing of the concrete.
And that keeps it at a state where it can be effectively poured and so forth.
And when it sets, it won't get too hot, which loses its strength. Now these buckets are 4 cubic yards each. They're picked up with an automatic clamp that they drop over the top of the bucket. And sure as you know, when the cameraman is looking at this thing and trying to get a shot of it, the man can't hit it. So he's trying and trying to snag that bucket.
Quite a bit of maneuvering to be done there.
He's probably 150 feet in the air.
Ah. And this is
in a
concrete
train.
here being
Right.
transferred
4
over.
yards in each bucket.
Now this is to be used to line the canal.
This particular concrete here is going into the pumping plant.
Oh, for the-
Again, a 10-story building sitting in a hole in the ground.
You can see the trailers in the background there.
The whole thing is reinforced concrete with steel reinforced concrete. You can see much of the steel sticking up there. This is going to be walls, and that.
Now that one is still kind of in the early stages of construction?
This one's about probably 3/4 of the way complete with the structure itself. Again, it lacks the internal hardware to make it a pumping plant.
Now, this part of the project was set to be completed by what date?
We are planning on having water into the Phoenix Salt River area in January of 1985.
So, roughly 4 years away from us here.
About 4 years away. Okay. 4 very busy years.
Okay.
Our back is to the wall to meet that schedule.
And do you anticipate that you'll be able to adhere fairly well to the schedule? Or?
We're planning on it, making every effort.
Each delay that you experience, I'm sure, is terribly costly in terms of inflation and costs rising for materials.
Interest during construction and inflation both make delay almost intolerable.
Almost intolerable. Now, could some of the controversy that is going on over the Central Arizona project, could it hamper or delay the development?
It could, but at this stage, there are other factors that probably are more liable to cause a delay than it is at the present time. But as we get down the road, the seriousness of these particular allocation delays compresses. And they then could become a factor. But right now there are other factors. Funding and other things are potentially more serious factors than it is. Funding has been very, very good in this project. This last year is $144 million we're presently operating on, which is a pretty sizable annual amount.
Okay. Now what's going on right here?
What you're seeing here is a machine that shapes the slope of the canal and puts a final cut on it before a lining machine comes along and lays concrete on it. Now this machine right here you see the truck driving up alongside of is a lining machine, a paving machine. It's very much like a paving machine that would pave a highway, except it is laying at an angle on the wall of the canal. They're poured in 2 separate sections. The contractor will go up one side and back down the other, so half a canal.
And that's just crawling along there.
It's moving. It's a little hard to see on the screen there, but this whole machine with the truck on it and everything else is moving. And this particular contractor laid 4,000 linear feet one side in 1 8-hour period.
Almost
this last
a mile.
fall. Nearly a mile in one day.
I imagine once they start up, they have to plan on keeping moving.
They don't stop for anything.
They don't stop for anything.
This particular contractor is Ball and Brosmer, and this is the same contractor that did the Coachella Canal lining over here near Yuma. And
we had some shots of that recently, in fact.
Yeah, they just recently made the cutover and took the old canal out.
We showed that in our news one evening. We showed some of the water being diverted over. It was very interesting.
Well, this same contractor has got a large portion of the Central Arizona project and a large portion of all the canals that are being built in the West.
That must be an awfully specialized, incredibly specialized operation.
It is specialized.
Are there other companies that actually do that?
Well, there's quite a number, but it seems recently that this particular contractor has been very successful in being low bidder.
Okay.
What you see here is several machines. One of them was the shaper at first, then the paving machine right there. That paving machine also has associated with it a device that places in the 4-inch thick concrete plastic strips that serve as weak joints, such that when thermal cracking takes place due to expansion and contraction from heating and cooling, or just movement of the earth, settling and what have you, that the canal will crack on those particular spots, and the plastic in the joint will seal it and it won't leak water. Otherwise, if it cracks, the water will leak through the crack.
That's similar to that's kind of a fancy expansion joint.
Right. And it also seals.
And a sealing mechanism. And here we're smoothing it, it looks like.
Right. This is followed in the following scene here with a jumbo that has people on it, manually doing a final finish.
So
This
there's
is
two stages in the finishing process there.
Right. The machine finishing and then the manual finishing.
On a typical day, how much of the canal can they actually complete? One side?
Percentage-wise, like I say, our big day was 4,000 feet. And I believe that was somewhat of a record for this particular job.
Uh-huh.
A lot of what we have built is things you don't see. They're the siphons going under rivers, tunnels and things like that. There's an area north of Phoenix that has rather large dikes on it that has been protecting Phoenix in the last 3 years in these heavy floods. We tried to build things that were useful first, such as dikes. The things next that wouldn't require any maintenance, such as tunnels and siphons.
So it's sort of a piecemeal approach, but it's very purposefully done.
Purposely done in that order.
Uh-huh.
There's just no way you can get manpower or funds to do it any faster, and so you have to try and schedule it in such an order that it gives you the most benefits and least costs. And
Ed, when was the project first actually conceived, the Central Arizona project?
Oh, it's been on the books for years. The earliest recollection of any seriousness, this is over here called Reach 12, and this is about the end of our tape. Next edge is the Salt River in the background, and that's it.
Okay.
The earliest recollection of any seriousness was in the 40s.
That far back?
In the 40s, early 40s, and it was looked upon then as a little bit differently, that they would bring water down from somewhat north of Parker, as far north up into the Bridge Canyon, Marble Canyon area. And it soon changed to more or less what it is today. And originally, Bridger Marble Canyon Dam was to be a part of the project and supply the energy for pumping. And then the environmental movement was blossoming in the early 60s and mid-60s when the legislation was going through, and they took the dams out and replaced it with the Navajo steam generating plant at Page.
I see.
Which was thought at that point in time to be more desirable than a dam, until after we got it nearly built, and then the environmentalists seemed to feel that the air quality degradation because of it was intolerable, and we spent several $100 million in addition just cleaning up the air.
In order to clean up the air.
Right.
With that project. Well, so when did the first construction actually begin on what is there today to be used?
My best recollection is around 1973 it began. It was Reach 11 of the Granite Reef, north of Phoenix.
Actually, some 30 years after some type of project of this kind was first envisioned.
Right. Water projects, generally speaking, are a very slow thing to nurture through Congress. If you came up with the need of a new project today, you could guess about 20 years before you would ever see it substantially completed.
That certainly calls for long-range planning and a lot of faith at the same time.
Yeah, the difficult thing about that is that the value systems about which the project first started probably have changed several times by the time you get into the construction stage. The Central Arizona project originally was to be a boon to the farmers in agriculture. But before it's even completed, it becomes obvious that it is not that.
Urban
in fact, it
interests
is a boon to the municipal and industrial interests, and that agriculture will be taking a lesser priority.
Well, now, Phoenix is, of course, first on the list as far as completion dates and water flow and so forth. But tell us a little bit about what's to follow then. What would be next?
Well, we expect water to go down south of Phoenix into eventually somewhere in the Tucson area. Again, because of the allocations and some other issues, we don't know exactly where yet. But Tucson will also be a recipient of CAP water, a very necessary recipient, because Tucson is the largest city in the United States that has nothing but a well-type groundwater supply. There's no surface water.
And that is becoming a critical
It's
concern.
depleting rapidly. So Tucson will be receiving CAP water.
Will they be able to, do you feel, continue at their present rate of development without facing a critical water shortage until CAP can bring them water?
I would guess that they would be, getting fairly close to a critical situation, if they aren't already there.
If not already. So in that respect, at least, urgency in terms of project completion dates and so forth is definitely there.
Right. Every year that goes by that we don't import more water into the central part of Arizona means we're, again, depleting more groundwater that was historic old water that probably will not be replaced. CAP is not the final answer. It is going to slow down the over-pumping of groundwater in Arizona, but it will not stop it. Other things are going to have to be done to stop it. And this is going to mean greater conservation, whether it is agriculture being removed, urban areas practicing more conservation measures. But CAP is not the final answer. It's just one.
It is not a panacea to southern Arizona's water problems.
No.
Okay, and I imagine getting that across to the public may be an important consideration, that conservation will still be necessary and other measures.
It's just merely stalling until some hopeful thing can be done down the road. Whether it will be augmentation of the snowpack in the Rockies is one potential way of getting more water into the Colorado. Other things are being considered, long-range importation, but these are a long ways down the road.
So we're, as you just mentioned, 20 years would be a quick time in which to implement a project that was conceived now.
Right.
Now, it's intriguing. You mentioned augmentation of the snowpack. What does that involve, just out of curiosity?
Well, weather modification, basically.
Weather modification?
Weather modification of the snow conditions on the west side of the Rocky Mountains in the Colorado watersheds. The Bureau of Reclamation, or is now called the Water and Power Resources Service, has been doing a great amount of research in this area, where you seed the clouds with silver iodide or some other similar type material and cause snow to fall at a greater amount under proper weather conditions. This, of course, as you can imagine, immediately has all kinds of interesting legal ramifications, because if a landslide takes a small town out, or a person, or causes hardships to people because of excess snowfall and so on, that is potentially a direct cause of man tampering with the weather and can create liability situations that are just unbelievable. So it may be a method, but it also has its drawbacks.
Okay, well, we've been looking today at the Central Arizona Project and its ramifications and possible completion dates, what it will do. It's obviously essential. It may not be the final answer, but it's a key part of Arizona's water future.
Absolutely.
Ed Hallenbeck, thank you for being with us, the project manager of CAP.
Thank you.
And thank you for being with us for this week's Dimension 13. We'll see you again next week.
You've been watching Dimension 13, KYEL's public affairs program, with your host, Dave Marquis.